Hi guys, welcome to another video. This is for week 14, surface area and volume of simple 3D shapes. Let's go straight into the notes. Okay, so these are the notes. Again, you can find these in Google Classroom, or if you don't have them, just ask me and I'll print them out for you in class. Hopefully by the end of the lesson, you guys will be able to name parts of a cuboid or a cube. It's a similar sort of thing. Find the volume of cuboids, prisms, and cylinders. Find the surface area of cuboids, prisms, and cylinders. And if we get time, I'll show you how to interpret plans and how to draw elevations. Let's have a look at parts of a cuboid first. So we need to label this. Let's have a look. Okay, let's do it in this color. So you need to know what the parts of the cuboid or a cube or any 3D shape, really, they have the same properties. So you should know that any flat surface, that's a face. So this is a cuboid and should have 6 faces. Yeah, including the ones behind as well. Obviously, we can't see them, but they are there. Anything to do with lines, that's to do with edges. And the vertices is just a fancy way of saying corners. So that's the vertices. Or vertexes, one corner. Yeah, vertices is plural. Yep, so you need to know what each property means. So they could mention the faces, they could mention the edges, could mention the vertices. A lot of people don't know what vertices are, but you need to know. Obviously, they could ask it in the question. Right, so I'm going to show you a formula that works for pretty much any 3D shape. There are a few it doesn't work for, which we're going to do in a different lesson. So this formula that I'm about to give you, this works for these types of 3D shapes. So you get things like cuboids, triangular prisms, and even things like these pentagonal prisms. Basically, any shape that's got a cross section. I'll explain what that is in a minute. So basically, you imagine the shape is a block of cheese. Yeah, think of it as a block of cheese. And the cross section is just, when you slice the shape, imagine you slicing this block of cheese. You want every slice to be the same. So if you start slicing this way downwards for the triangular prism, if you keep slicing, keep slicing, you're going to end up with different slices. So I can't use that as my cross section. If I start slicing from the top instead, I keep slicing, that would make all the slices the same. So technically the cross section has to go throughout the shape, has to be the same shape that goes throughout that 3D shape. Yep. So yeah, you just have to figure out which bit is the cross section first for these 3D shapes, and it's quite important in understanding how to work out the volume then. So imagine the shape is a block of cheese, and the cross section is a slice where every slice is the same. Every slice is the same. Yeah, so that's the idea behind it. So you have to think of which bit is my cross section and work out something which I'm about to tell you in a minute first. The key thing is figuring out which bit is the cross section. Yeah, and understanding how to work out the volume. So if you turn over the next page, the formula is you need the area of the cross section. The cross section could be any shape, as we've just seen. area of the cross-section multiplied by how long that 3D shape is. So we just call it the length. The length of the 3D shape, let's just call it length. Yeah, so area of the cross-section, work that out first, multiplied by how long the shape is. So here's an example. You could have any shape, any weird shape like this. If we knew the area of this shaded part here first, and if we knew the length, we can very easily work out the volume just by multiplying those two numbers together. So it works for pretty much any 3D shape, including, if we go back, cuboids or cubes, triangular prisms, and even these weird shapes, even this weird shape as well. As long as you can see a cross section that goes straight through the 3D shape, then this will definitely work. So it'll work for most 3D shapes, but apart from, it won't work for things like cones. If you imagine a cone, obviously if you slice it, it doesn't matter which way you slice it, all the slices are going to be different anyway, so we can't use it for that, definitely. Things like pyramids, again, same sort of thing. Doesn't matter which way you slice it, all the slices are going to be different, so we can't use it for that. And the other shape it doesn't work for is spheres. Yep, so if you try and slice a sphere, it doesn't matter which way you try and slice it, again, all the slices are going to be different. Yep, so you will have separate formulas for these 3D shapes, which we're going to do at a different week and a different topic in a different video. So don't worry about these 3 cones, pyramids, and spheres. We're going to look at them some other time. So for now, let's just have a look at this formula. Volume equals area of cross-section times length. We're going to use it for the following questions. So I'll tell you what. If you want to try it yourself, by all means, you can pause the video and give it a go. Once you're ready, just unpause it. Let's have a go with this then. So work out the volume of the following shapes. First things first, which bit is a cross-section? Always ask yourself, which bit is a cross-section? So in this case, my cross-section is this shape here. In fact, let me just, don't want to hide that because I need that. So this shaded bit here, which is in the shape of a triangle. So I need to work out this area of this triangle first. We know that area of triangle is half base times height, or base times height divided by 2. Let's do it that way. What's my base? What's my height? So the base is 10. Height of the triangle is 6. And we halve it. So that's going to be 30. That's going to be centimeters squared. Yep, so that's the area of the cross-section done. Our formula is volume equals area of the cross-section, which is that, 30, multiplied by how long this shape is, which is technically that length from there to there, which is 20. So it's going to be 20 multiplied by 30, 600. That's going to be a centimeter cubed. Yeah, so anything to do with cubed is to do with volume. Anything to do with squared is to do with area. Yep, don't forget the correct units. That's that one done. Next one, where's my cross section? So imagine every slice being the same. It's definitely going to be this L shape at the front. So we're going to have to work out the area of that L shape. Tell you what, let's split the shape this way. You can split it whichever way you wish. Let's call that shape A, and let's call that shape B. So area A is going to be length multiplied by width. That's going to be 44 centimeters squared. Area B, let's work that out separately. Well, I've got 5 for my length. I need this bit here, the width. Well, if it's 7 all the way across from there to there, take away 4. 7 take away 4 gives me 3. You could have done it differently. You could have split it down here, for example. You would have got the same answer for the total, which I'm about to do. So that's 15. So the total area for the L shape, 44 plus 15. What's that? 59 centimeter squared. So that's the area of the cross section done. The volume is going to be that multiplied by how long the shape is, which is 20. So it's 59 times by 20. Let's work that out. We get 1180. Yep, and it's got centimeters cubed in the on the dotted line. That's fine. Yep, that's your answer for that one. Next one, we got cylinder. So it works for cylinders as well, definitely. We've got a cross section. Technically, our cross section is this bit here on the top. Yeah, that's my cross section there, which is in the shape of a circle. So we need the area of a circle, which is pi r squared. So it's going to be pi times 3 squared. I'll tell you what, let's not write it as a decimal. Let's just leave it as 9 pi, because obviously 3 squared gives you 9. Let's leave it like that, because I'm going to use this in a minute. If you write all those decimals, you can, but I wouldn't recommend it. It's just a waste of time. Let's leave it as 9 pi for now. So the volume is going to be 9 pi times how long the shape is, 10. That's going to be 90 pi. Okay, now we need it as a decimal. Let's change 90 pi into decimals, press SD. Get 282.74338. And it goes on. Let's do it to 1 decimal place. No, in fact, let's do it to 2 decimal places. Let's be a bit more accurate. That's fine. Yeah, that's good enough. If it doesn't say in the question, give your answer correct to 1 decimal place or 2 decimal places or 3 significant figures, you could do your own. They will give you obviously a range in the exam for your answers. I think 2 decimal places is good enough, to be honest. Yeah. Let's move on to more difficult volume questions. Diagram shows a container. Container is in the shape of a cylinder. Container is empty. Jack has a bucket. He's going to use the bucket to fill the container with water. Bucket holds 10 liters of water. How many buckets of water does Jack need to fill the container? You must show you're working. 1 liter is equal to 1,000 centimeter cubed. Okay, 4 marks. This looks like a functional skills type of question. Functional skills level 2. Very similar sort of style, isn't it? So obviously it's to do with volume. We need to work out the volume of this container and work out how many buckets we need to fill that. Okay, we'll get to that in a minute. Let's work out the volume first. So again, your cross section is going to be that bit there, which is a circle. That's going to be what happened there. So let's do pi r squared. So it's going to be pi times, well, 50 is going to be the diameter. So the radius is going to be half of that, which is 25 squared. What's that? 25 squared, is that 625? Yeah, let's leave it like that, 625 pi. Okay. So the volume will be 625 pi times how long the shape is, 90. Let's do that. 625 times 90. 56250 pi. Let's leave it like that for now. Don't want to write all those decimals. Let's keep it like that for now. No, in fact, we do need it in decimals now, because I'm going to change it from, this is technically in centimeters cubed. We need it in liters, and we need to use this, definitely. So let's write it as a decimal. Previous answer times pi try that again. 56250 pi. Right. It's a lot of numbers. 176714.5868. Okay, that's going to be centimeters cubed. Let's change this to liters. So we're going to have to divide by 1,000. How many thousands go into that? That's going to give me 23176.7145868, and that's going to be in liters. All right, so about 176 liters can fill this container. Okay. What's next? A bucket holds 10 liters of water. So how many 10s go into that? Let's use that. Divide by 10. It's going to go back once. So it's going to be 17.67145868. And this will be number of buckets. How many buckets does he need? So 17 wouldn't be enough. So I'm going to need 18 buckets. Yeah. That's your answer. 18 buckets. Definitely like a functional skills type question. Yep, just do it step by step. Obviously work out the volume. That's going to be in centimeter cube. Change it to liters. And how many change to buckets afterwards. That's your answer. Have a go at the next ones yourself. Pause the video. When you're ready, unpause it. Right, let's go through this one. So diagram shows a cuboid. Width of the cuboid is 5 centimeters. Length of the cuboid is 8. Volume of the cuboid is 120 centimeter cubed. Okay, so you're told what the volume is. Work out the height. So we want this. That's what we want. Let's call that H. So when you're told the volume in the question, you have to work backwards. Yes, obviously we know that volume is equal to the area of cross-section times the length of the shape. Well, we know what the length is. That's the length right there. Well, in fact, no, that's not the length. I'll tell you what, for a cuboid, you can use any face as the cross-section. Doesn't matter which way you slice it. Every slice will be the same, whether you slice it from the front, whether you slice it from the top, whether you slice it from the side, makes no difference. In fact, I'm going to use, because we've got these two values here, 5 and 8, I'm going to use that as my cross-section. So this bit here, I'll highlight it. This bit here, which is technically the base, let's use that as my cross-section. That's perfectly fine. So that gives me, so that's that bit there, the area of the cross-section, which is 5 times 8, which is 40. So that goes there, times the length, which we don't know. Well, the length is that bit there, technically, which is H. Let's call that H. Volume we know is 120. That goes there. Let's rearrange this and get H on its own. So H will be 120 over 40, which gives you 3 exactly. That's going to be 3 centimeters. There's your answer. Yep. And that's going to be your final answer, 3 centimeters. Yep. So just work backwards, definitely. And you can technically use any face for the cross section for a cuboid. I'd go from there. Let's have a look at the next one. John wants to fill a box with grit. Bag of grit costs £2.50. There are 8,000 centimeter cubed of grit in a bag. John has £70 to spend on grit. Does John have enough money to buy all the grit? Right. Again, very similar to a functional skills type question. Let's work out the volume first. A little trick as well. If you've got a cuboid, all you can do is just multiply all 3 of these together. It's the same as the area of the cross section. Let's call that the area of the cross section. That bit there, which is 60 times 100, multiplied by the length, which will be 40. It's the same thing, isn't it? Just multiply all 3 together, and it's a cuboid. Let's see what we get. Oh, 240,000. That's going to be centimeters cubed. Okay. So each bag can hold 8,000 centimeter cubes. So how many 8,000s go into that? $30. So it's going to be 30 bags. How much is each bag? £2.50 times by £2.50. £75. Has he got enough? Nope, he's got £70, so no. Let's say he needs an extra £5 or something along those lines. Yep, maybe he can borrow £5 off his mate or something. Something along those lines, that's fine, that's good enough, that's 5 marks. Question 2C. Jane makes cheese. Cheese is in the shape of a cuboid. Okay. Jane is going to make a new cheese. The new cheese will also be in the shape of a cuboid. Cross section of the cuboid will be 5 by 5 centimeters square. Okay, yep, we can see that. The front. Jane wants the new cuboid to have the same volume as the other cuboid, the 2 by 10 by 15. Work out the value of x. That's there. Right, that's the length of the shape. So they're saying the volume is the same for these shapes. So let's work out the volume of the first shape. Let's do that up here. Again, let's just multiply all these together. Quick way of doing it. What's that? 300 centimeters cubed. Okay, so that's going to be the same as this cuboid. Let's say this is your cross section. Okay, so volume is equal to area of the cross section, which we can easily work out, times by the length, which in this case is x. Well, let's just put length first, which that's our formula. Volume we know, which is 300 from the previous cuboid, sorry. Area of the cross section, well, the area of the cross section is 5 times 5, which is 25, times by the length, which in this case is x. Let's just leave that as x. So that's going to be 300 divided by 25. Let's work that out. You get 12. That's going to be 12. Be your answer. Yep. Work out the value of x is 12. Let's move on to surface area. So surface area is different to volume. Obviously, volume is to do with how much the shape can hold, or how much you can fill it with. So it's a space that the container can that you can fill. Whereas a surface area is just the area of all the faces of the shape. You'll have to work out the areas separately. Some will be the same, like the front will be the same as the back, the top will be the same as the base, and so on. Depends on the shape. So you could get your answer in no time. You just have to add all the areas together, and your answer will still be in centimeters squared because it's still to do with area. So very different to volume. Obviously, it's to do with the same kind of shapes, 3D shapes. They could technically give you the same shape. They could very easily ask you, what's the volume, which is one method, and they could very easily say, what's the surface area of that same shape? It would be a completely different method as well. Yeah, so let's have a go of this example right here, and I'll show you. So diagram shows a cuboid. Work out the total surface area, right? So you can call these faces anything, just to make sure that you've not missed any. Let's call this one the front. Work out the area of that. What's that? That's going to be 8 times 10. Yeah, that's going to be the same as the back. Okay, let's just put it there. That's that done. Let's call this the right-hand side, which is going to be 5 multiplied by 8. That's going to be the same as the left. That's that done. Let's do the top, which is 10 times 5. And that's technically going to be the same as the base, which is that. You should have 6 faces on a cuboid, isn't it? So it's the front, the back, the top, the base, the right, and the left. Yeah, so it's 6 faces all together. Add all these up, and you should get 340. And that's going to be, just double check, centimeters squared. Don't forget the centimeters squared. Yep. Have a go at the next one yourself. Pause the video. When you're done, just unpause it. Okay, so let's have a go at this one. Again, I'm going to call that the front. Ten times 5, which is 50. That's going to be the same as the back. Let's do the right-hand side. You can do this in any order, by the way. You don't necessarily have to do it in this order. Right-hand side is going to be 5 times 6. That's going to be the same as the left. And the top, 10 times 6. That's going to be the same as the base. Yep, 1, 2, 3, 4, 5, 6. Let's add them all together. $280. Okay, so that's 280. Is it in centimeters? Yeah, centimeters squared. Yep, dead easy. Let's move on. Work out total surface area of this, right? Okay. So this is slightly different. This is different to a cuboid. How many faces have we got? We've got 2 triangles. That's 2. 3 for this bit here. 4 for the back. 5 for the base. You've got 5 faces. Let's do the triangle bit first. That's going to be base times height divided by 2. What's that going to be? 12.6 for that. Okay, and we've got two of them. That's that one. So yeah, they're both the same. Both those triangles are the same. So that's that done. Let's call this the front. This bit that's so it looks like it's like a little slidey bit. That's it's the shape of a rectangle, which is 5 times 7, 35 for that. The back is that bit there. That's going to be 3 times 7, which is 21. And the base, let's call that the base, like that, which is 4 times 7. Yeah, so they're all different, apart from the triangles. Just be careful with this one. Is that 5? 1, 2, 3, 4, 5. Yeah. Add all these together. We get 96. That's going to be centimeters squared. Okay. Yeah. Dead easy, these. This is, to be honest, this is mainly foundation stuff. But you need to know this before you move on to the higher topics. Okay, so let's have a look at more difficult surface area questions. Again, this is taken from past paper. Jeremy has to cover 3 tanks completely with paint. Each tank is in the shape of a cylinder with a top and bottom. The tank has a diameter of 1.6 meters and a height of 1.8 meters. Jeremy has 7 tins of paint. Each tin of paint covers 5 meters squared. Has Jeremy got enough paint to cover completely the 3 tanks? You must show how you get your answer. Again, yeah, actually, this is quite tricky because nothing to do with volume. This is to do with surface area. So the paint is going to be on the outside of this tank, including the bottom that they're talking about. So they're saying it's got a top and a bottom. It's going to completely be covered in paint on the outside. The clues there as well. Each tin of paint covers 5 meters squared. So anything to do with meters squared or units squared, definitely to do with area. Yep. So if you start working at the volume of this shape completely wrong, you won't get any marks. Let's work out the surface area then. So we definitely need the area of the top. Let's do that first. That's the shape of a circle. So that's going to be pi r squared. I think it's always a good idea to write the formula down just to remind yourself, what do you need? Because in this case, I need pi. And now I need the radius. But what have they given us? They've given us the diameter, that 1.6 meters. So we're going to have to halve that, which is 0.8 squared. So don't fall in that trap of putting 1.6 squared, which is a very, very common mistake. So that's squared. Let's call that 0.64 pi. Okay. Let's leave it like that for now. Okay. And obviously we've got 2 of them because it's the same at the bottom. So let's times that by 2. Times 2 is 1.28 pi. Yep, that's that bit done. So the two circles are done the top, I've done the bottom. The only thing left is the bit that goes around the cylinder. So if you think of the cylinder as a tube, and when you something like that, and when you unfold it, or if you cut down the center, in fact, cut down the center of the tube and then unfold it, you've got a cylinder. Not a cylinder. You've got a rectangle. So when you just unfold, like if let's say you cut it down the center like that, cut it down there and unfold it, you're going to get a rectangle. Let's draw what they're talking about. So the height is the same as this bit here, the 1.8. And the length is going to be the same as the circular bit at the top. Well, it's the circular bit is that bit there. It's all the way that goes round here, that bit there. That's technically the circumference. So I need the circumference of the circle, which is going to be pi times d. Well, the d is 1.6, so it's pi times 1.6. Let's call it 1.6 pi from there to there. In fact, let me just write that in the middle. 1.6 pi. Yeah, and that's from there to there. So the area of this shape is going to be 1.6 pi times 1.8. Let's work that out. 1.6 times 1.8. 2.88 pi. Don't forget the pi. So the total area for one tank, total area for one tank is 1.28 pi plus 2.88 pi, which gives us 4.16 pi. Okay. We need that as a decimal. So we can change it now. 4.16 pi. No, in fact, you know what? I'll tell you what. Let's leave it like that for now. Let's times it by 3. Because that's for one tank, yeah? That is for one tank. That's for one tank. Let's do it for 3 tanks because you have to paint 3 tanks completely. Let's times that by 3. So 3 tanks is equal to 4.16 pi times by 3. Okay, and now we can SD it, which gives you 39.20707,632. Ideally, you want to write as many of these decimals as you can when you get near to the end of your question, because you want to be as accurate as possible. If you start rounding halfway through your answer, your final answer will be slightly off, and you could be wrong by one or 2 decimals. So you need to be as accurate as possible. I would only round right at the end of your answer, not in between. So in this case, I would be as accurate as possible, even if you can write as a fraction to begin with. When we had the pi, when I had 4.16 pi, if it came up as a fraction, that's absolutely fine. Or if you can write it, if it's not that many decimals, then you can just write 4.16, which is not too bad. This one here, when I had to times it by 3, I had loads of decimals, so I had it as a big fraction as well. So now I think is a good time to write all the decimals that we need. That's going to be in meters squared. Okay. This is the area of 3 tanks in meters squared. Okay. How many tins of paint? Well, each tin of paint covers 5 meters squared, so we need to divide that by 5. Divide it by 5. So just divide your answer by 5. So don't clear your calculator. Your calculator stores your previous answer. Just keep it on screen. I would, and just what I just did was just press divide by 5 equals. We got 7.841415,263. What does this represent? This represents number of tins. Yeah, because each tin represents 5 meters squared. So that's going to be tins. He's got 7 tins. Well, technically 7 wouldn't be enough. He needs more than that. We need 8 tins. Has he got enough? No, definitely not. He's 1 tin off. Has Jeremy got enough tin? So we have to say no. He needs 8 tins. Yeah, or something along those lines. He's only got 7 tins. He needs 8. And there is your final answer. Just do it step by step. Yeah, surface area of a cylinder is a little bit weird. Just think of it as an A4 sheet for the bit that goes round, and just unfold it. You know, it's a rectangle. That's basically how you do that. Have a go at the next one yourself. Pause the video when you're ready. Just unpause it. Okay, let's have a go with this one. So work out the total surface area. Let's do the top. Pi r squared. That's going to be pi times 3 squared. Let's leave it like this, 9 pi. Again, I'm not going to write all those decimals be there forever, because this is not our final answer. Obviously, you can have one for the bottom, which is going to be 18 pi. And now for the bit that goes, the bit that goes around, I would actually draw that, because I think it helps. When you unfold it, the height is that bit there, from there to there, which is 10. This bit here is the circly bit here, the circumference of the circle, which is going to be the diameter. So it's going to be pi d, but the diameter is going to be 6, so it's going to be 6 pi for that, from there to there. Yep, that's that. So the area of that is going to be 6 pi times 10. That's going to be 60 pi. So the total area is going to be 18 pi plus 60 pi, which is 78 pi. If it says give your answers in terms of pi, I'd leave it like that. Or if it says give your answer as a decimal, or correct to 2 decimal places, or 3 significant figures, or anything like that, obviously you're going to have to do it as a decimal. I'll give both in this case, because it didn't specify. 78 pi is equal to 245.044227. Let's call it 245 centimeters squared. Yeah, that's good enough. Okay, so we got loads of faces in this one. This is quite tricky. Let's do the L shape first. I'm going to have to split this. I'll tell you what, let's split it this way. It's probably easier. You could split it the other way if you wanted to. Let's call this shape A. Let's call that shape B. That's going to be 3 times 1. And area B is going to be 4 times 1. So I could see straight away total of L shape is going to be 7. Add these two together. 7 centimeters squared. That's the L shape done. I could see straight away that, if I had these dimensions, let me split it this way, it'll just make my life a lot easier to work out the area. So we've got 2 of those L shapes, one on the front, one on the back. Okay. Let's call this one shape 1. So area of 1. It's going to be 1 times 6. That's that done. Let's call this shape 2. That's going to be 4 times 6, which is 24. Let's call that shape 3. What's that going to be? I need this, which is, if that's 1 there, that's 3. That's going to be 2. 2 times 6. Okay. Let's call that 4. It's going to be 1 times 6. Okay. The one on the back is going to be 3 times 6. Yeah, 3 for the height, 6 for the how long it is. Yeah, 3 times 6. Definitely, that's the back. Yeah, or you can call it something else. I'm thinking of the back of the L shape on this side. Let's call that the back. In fact, let's just put a B back, because I'm going to call the bottom the base. Yeah, let's do that. Let's call the bottom the base. So the base is going to be 5 times 6, which is 30. And don't forget, you've got 2 L shapes. So that's going to be 14. Is that all of them? I'm pretty sure that's all of them, isn't it? Yeah. There is a quicker way, but I just thought I'd do it this way. Let's just work out all the areas separately. Sure, there isn't a quicker way, because obviously all the area of the top ones, the ones that are facing up from the top, are going to be the same as the whole of the base. Let's just do it this way. It's absolutely fine. So it's going to be total surface area is going to be 14 plus 6 plus 24 plus 12 plus 6 plus 18 plus 30. Do correct me if I've gone wrong somewhere, if I've missed any. Apologies, but I'm pretty sure I've done it right. Do let me know if it's wrong though. 14 plus 6 plus 24 plus 12 plus 6 plus 18 plus 30. 110. Is that right? I don't have the answers here, by the way. I'm just working out same as you guys. 110 centimeters squared. That's going to be. Yeah, like I said, do let me know if it's wrong though, but it should be correct. Just make sure that you've not missed any. So I did the L shape. Did that one, then that one. Yeah, it's right. It's probably the longer way doing it this way, but yeah, it guarantees that you get your answer. It's absolutely fine. Next one. Here's a diagram of a tube in which the center is hollow. Oh, this is a good one. Find the surface area of this hollow tube. Okay, that's a really good one. So technically, we need, let me shade it in. We need this bit here. Just shade that in. We need the, let's work out the, if it's surface area. Yeah, I still need that. I still need the area of this. I was thinking of volume, but obviously it's asking for surface area. We still need the area of that bit there that I've just shaded in red, which is technically the big circle. Take away the smaller circle. Yep, let's do the big circle first. Big circle area is going to be, that's going to be the radius there, 3. So that's going to be pi times 3 squared, which is 9 pi. And the small circle area, which is pi times 2 squared, which is 4 pi. So shaded, let's call it the shaded area, is going to be 9 pi take away 4 pi, which is 5 pi. Let's just leave it like that. 5 pi for the top bit, 5 pi for the bottom bit. That's going to be 10 pi. So that's that done. And the bit that goes round, again, that's going to be in the shape of a rectangle. So that's going to be 4. And the top bit is going to be the edge of the big circle. That's going to be the diameter of the big circle is going to be 6 then. So that's going to be 6 pi. So the area of this is going to be 6 pi times by 4, which is 24 pi. So total is 10 pi plus 24 pi. Which is 34 pi. So if it said give it in terms of pi, I would leave it like that. It doesn't say that though. Let's just do it as a decimal. 34 pi, which is 104. Sorry, 106, not 104. 106.814. 1502. Let's do it to one decimal place, so it'll be 106.8. Let's do it to 2 decimal places. Centimeter squared. Yep. That's that done. Okay, yeah, so those are the main questions, and have a go of the next ones yourself. Again, the extension questions, and once you're done, so pause the video and just once you're done, you can just unpause it. Okay, let's go through this one. So extension question 1, Ali has some packets. Each packet has dimensions 40 by 8 by 50 centimeters. Ali fills a container with these packets. The container is a cube of side 2 meters. Okay, Ali fills the container completely with these packets. Work out the number of packets. Okay. Okay, so this type of question, technically you could work out the area of the container separately, work out the area of the packet separately, and see how many of those go into that. I'm going to do it a different way though. I'm going to see how many of these go into this. So how many 40 centimeters go into 2 meters? So how many can fit along this way? How many can fit this way? And how many can fit this way? So you're gonna have to divide. So 2 meters, let's call that 200, obviously. And that's 200 centimeters. Divided by 40, how many 40s go into that? It's 5, isn't it? Let me just double check. Yeah, so you can fit 5 going this way. Again, 200 divided by that bit there, which is 50. That's going to be 4. And 200 divided by 8. 200 divided by 8. Oh, yeah, it does go 25 times. So it's going to be 5 by 4 by 25. That's how many you're going to have. So 4 times 5 times 25. 500. 500 packets. Yeah, that's your answer. Fills it. There's no gaps. It fills it completely. You can fit 5 going that way exactly, 4 going that way, 25 going that way. you'll get 500 packets. You could have worked it the other way. Like I said, you could have worked out the areas, sorry, the volumes separately, and just see how many of those smaller volumes go into the bigger volume, and you'll get the same answer. You'll get 500 exactly. Sometimes it doesn't work. Sometimes they don't exactly fit in the boxes. Sometimes you'll have gaps, and that space that's left, it goes to waste. So ideally, you should do it this way, like I've shown you. This type of question. I would see how many you can fit along there, how many can fit along there, how many can fit along there. So again, it's very similar to a functional skills type of question. I've seen these before in functional skills, and it's a really good way of doing it, and it guarantees that you don't get any gaps or anything like that in there. If they fit exactly in there, then definitely do it this way. Yeah, and it's a really good way of doing it. Next one, here's a prism. Oh wow, look at that. Work out the volume of the prism. Wow, how many marks is that for? So we're gonna have to work out the volume with the formula. Cross section times the length. So technically, the cross section in this case is that front end shape, isn't it? That bit there. You could work out these separately. So all of this separately. Work out this separately. And then work out this separately, which is going to be the same as the first shape. Could do it that way. Is there an easier way though? That's going to take a bit of time. Let me just see. Oh, I tell you what. You know what you could do? Let me just delete all this. Quicker way would be to complete this front face. The only thing that's missing are these two triangles. Can you guys see this? This bit here. There's a triangle missing there, and there's a triangle missing there. Apart from that, it's a complete rectangle. Yeah, it's a much quicker way, isn't it? So let's work out one of these triangles. They're going to be the same anyway. Just double it. So let's work out the area of one of these triangles. Well, from there to there is going to be, if that's 10 all the way across there, that's going to be 3, that's going to be 7. So what have I done that in red? Let me just... so it's going to be base times height divided by 2. Base is 4 times by 7. So that's going to be 28 divided by 2, which is 14 centimeters squared. We've got 2 of them. They're both the same. Yeah, from there to there's 7. That's going to be 4. It's the same. So 2 of them is going to be 28 centimeters squared. The area of the rectangle, the front face, is going to be, if it's a complete rectangle, it's going to be 10 times, what's the bottom going to be? 4 plus 2 plus 2. That's going to be 8, which is 80 centimeters squared. So technically the end shape is going to be 80 take away 28. What's that? Yeah, it's a lot quicker, isn't it? Definitely 52 centimeters squared. There's my area of my cross section. So that's the area of my cross section multiplied by how long the shape is. So basically, how much does it go into the page? And it's that one. That's my cross section. That's my length right there. Sorry. So it's going to be, volume is going to be the cross section multiplied by how long the shape is, or how deep the shape is in this case, times by 1.5 78 I get as my answer. So 78 centimeters cubed. That's a good one, that one. So if you can't see it to begin with, some people were saying in the class, oh, I couldn't see those triangles. I couldn't see it at first to begin with as well, and you could have done it the other way. Like I mentioned, you could have worked out the area of that bit there. You could have worked out the area of this bit here, the slanted bit, and you could have worked out the area of that, which is the same as that. You could have done it that way. You would have eventually got your answer. But it's just, some methods are quicker than others. Makes no difference as long as you get the right answer. That's the main thing. Let's move on. Plan front elevate right. Okay, this type of question. Again, how many marks is this? Let me just have a look. 2 marks for this. Okay, yeah. This is one of those questions that you either know it or you don't. It's just one of those things where you can either visualize it, or you can't visualize it. And it's not the end of the world if you don't know how to do this. It's only 2 marks. I wouldn't spend ages on something like this, but I'll show you how I do these. So they've given us the plan, the front elevation and the side elevation on a centimeter grid. Okay. In the space below, draw a sketch of the solid prism. Write the dimensions of the prism on your sketch, right? So basically what they're saying is that this is a 3D shape. They want you to draw the 3D shape, what it is, what it looks like. So plan is what it looks like from the top, if it was from a bird's eye view. Front elevation is obviously from the front. Side elevation is obviously from the side. I would always start off with the front elevation, because the front is always from this direction going this way. Yeah, so the front always is going that way. So I would draw the L shape. Oh, it's a bit of a wonky shape. And it says sketch as well, so you don't have to be accurate as long as you got the right dimensions. That's good enough. That's the front bit, which is a L shape. So this bit here, the height of the L shape is 1, 2, 3, 4 centimeters here. That's going to be 1, 2, 3, 4, 5 along here. And I'll come to the other ones in a bit. That's going to be 2 centimeters there, by the way. The top bit is going to be, in fact, let's do the top bit there. I could put 3 centimeters here. That's good enough. So that's the front bit done. Let me zoom out. In fact, let me zoom out a little bit, just so we can see all of these. So the side elevation, and let me do that. So this is basically this bit here. Let me shade it. This bit here is the bit sticking out of the L shape. That's that bit there that's sticking out. So this bit here is technically, if I shade it there, that's that bit there that I've just shaded. And let me shade this in a different color. Hopefully this will make sense. This bit here is that bit there, that face that we can't see. Obviously, we can't see it on the front elevation, but we can see it on the side elevation. When you look at from the side elevation, you're only going to see them 2 faces. So you're not going to see the perspective. So we've got, let's just extend these. Something like that. I'll do the top. In fact, yeah, let's do the top as well. The top's going to be the same as well. Oops, that's not good. When you do these as well, make sure you do it in a pencil, definitely in a pencil. You don't have to use a ruler for this because it's a sketch. That's better. That's good enough. That's pretty cool. That's what the shape looks like. Yeah, that's what it is. Yeah, let's just double check the plan. Again, the plan is going to be this bit here, this green bit here is that there. And let me try a different color. In fact, let me do it in, I'll do it in black. And this bit here is this, which again, you can only see from the top. You're not going to see it from any other angle. So if it helps, obviously you can't draw it, you can't color these in the exam, but if it helps, let me shade in these like I've done on here so that you can see which bit is which. That's the green bit, and that's that bit there. Yeah, so I've color coordinated it just so for those who you know, not sure what it looks like, where these faces are actually coming from. And don't forget, because you have to write down the dimensions as well. I've done 4, I've done 5. What was this one? This was 1, 2, 3 this way. This is a height of 2. This has got 2 as well. That's got a height of 2 for the blue bit. And the top bit there is 1, 2, 3. And this bit here is the same as the side elevation, yep, which is 3. So that should be 3 there as well. Yep, that's good enough. That's your answer. So yeah, don't spend ages on something like this. Obviously, I'm spending ages just to show you guys what it looks like. I would always start off with the front. Start off with the front side first, and then go from there. Yeah, like I said, don't spend ages on this. Let's move on. Extension question 4. Total surface area of a cube is 294 centimeters squared. Work out the volume. Okay, and there's no diagram. Cube. What do we know about cube? Let's draw what they're talking about. Just draw any cube. Okay, they're saying the volume. No, sorry, they're saying that surface area is 294. But the surface area is just all the faces, the area of the faces added together. How many faces we got? Should have 6 faces. So one face area is that divided by 6, because all the faces are the same. That's going to be, let's work that out, 294 divided by 6, 49. Ah, I see where this is going. So let's imagine that one of these faces is 49 centimeters squared. That's your length. That's your width. Because it's gonna, again, it's because it's a cube, all sides are the same. Let's call that x. That's going to be x as well. So something times something gives you 49. What's that something going to be? So x squared equals 49. So x is going to be the square root of 49, which is 7 centimeters. Okay, so the volume, now we can work out the volume. So that's 7 times 7 times 7. Yep, if it was a cube, let's multiply all 3 dimensions. 343. That's going to be centimeters cubed. Yep, 4 marks for that. That's pretty good. Next one. Diagram shows a prism. Cross section of the prism is in the shape of a trapezium. Okay, calculate total surface area. Oh, and then it says calculate the volume. So for the same shape, we're going to have to work out total surface area. And later on, we're going to have to work out the volume. Wow. Let's do surface area. It's like it said, the cross-sectiony bit is that front bit there. That's a trapezium. So how do we work out area of trapezium? What was the formula? Is that funny? A plus B divided by 2 times the height. A plus B is those two parallel sides always. So you got to do 7 plus 15 divided by 2. The height is that vertical height right there, which is 6. Let's work that out. So that's going to be 7 plus 15 is 22. Half of it, that's going to give you 11 times 6 is 66 centimeters squared. Okay, that's going to be the same as the back. So the back is 66. Let's do the top, which is in the shape of a rectangle. That's going to be 7 times by... Ooh, what is that? Can we work that out? We can't. Don't know what this is. What's this going to be? Oh yeah, it's going to be 8. It's the same as that. Blimey. 7 times 8. Yeah, that's going to be 8, isn't it? Definitely. 7 times 8, which is 56. Okay, that's that bit done. Let's do the right-hand side. That's going to be 5 times 8. Same as the left. And the base, let's call that the base there, is going to be 15 times by 8. 120. That all of them. It's got the top, the base, that side, that side. Yep, 2 of those. Yep, so total is going to be 66 plus 66. Plus all these. Yep, let's add them all together. 66 plus 66 plus 56, 40, 40, oops, and 120. 388 centimeters squared. Yep. That's good enough. What have we done there? Area of the trap. Yeah, so that's that bit done. Then it says calculate the volume. So again, we're going to need, well, area of trapezium, which we've done. Area of trapezium. You can work it out again if you want. Technically, no, you don't have to because it's part B. 66. And so the volume is going to be 66 times the length of the shape. So basically how deep it is. So it's from there to there, which is the same as that, which is 8. So it's going to be 66 times 8. 528 centimeter cubed. Yep. So see, you got the same shape, but 2 different answers for surface area and the volume. Yep. So don't assume it's going to be the same. Totally different methods as well. In fact, they both use the area of the cross section though at some point. But then it just goes completely different then after that, doesn't it? Let's have a look at the next one. Diagram shows a cylindrical tank. The tank has a top and a bottom. 4 of these tanks are going to be painted. Each tank has a diameter of 50 centimeters and a height of 1.5 meters. Ooh, okay, so that's in centimeters, that's in meters. Just be careful. Each pot of paint can cover 4 meters squared. How many pots of paint on it? I'll tell you what, because they're using 4 meters squared, let's keep everything to meters. So let's change that to 0.5 meters. Yeah, that's better. So let's do the, first thing to ask yourself, is it to do with volume? Is it to do with surface area? Because it doesn't say in the question. You have to figure that out yourself. Well, if it's to be painted, it's going to be painted on the outside, all the surface. And there's your big clue as well. Units squared. It's definitely to do with surface area. So let's work out the area of the top first. Let's do that. Area is pi r squared. Or apple pies are 2. Remember the little rhyme? Cherry pie is delicious. Apple pies are 2. It's a good way of remembering. So it's going to be pi times, what's the radius? Well, if it's 0.5 for the diameter, it's half of that, which is 0.25 squared. What's that going to be? Wow, looks a bit weird. 0.0625 is right. Pi, let's leave it like that. Okay. Tank has a top and a bottom. The reason they've mentioned that is because they want you to cover the paint on both top and bottom. So we're going to have to times that by 2, which gives you 0.125 pi. Okay, that's that bit done. The bit that goes around the cylinder, let's do that. That's going to be 1.5 here. And pi times d, which is pi times 0.5, so it's 0.5 pi. Yep. Area of that, 0.5 pi times 1.5. Let's work that out. 1.5 times 1.5. 0.75 pi. Okay. So total area for one tank. Don't forget, there's going to be 4 tanks. Let's do it for one first. 0.125 pi plus 0.75 pi. See, I didn't write all those decimals. I'd be there forever if I started writing all those decimals. You know, if I didn't do it in terms of pi, it'd be very messy. And, you know, you could get it wrong as well for your final answer eventually, because you're not going to be completely accurate. Let's work this out. In terms of pi, that plus 0.125, I get 0.875 pi. Okay, that's for one tank. For 4 tanks, it's going to be 0.875 pi times by 4. Let's times that by 4. 3.5 pi. Okay. So in fact, you know, when you multiply by 4 and then divide by 4, because we need to divide by 4 because each pot of paint can cover 4 meters squared. So how many 4s go into that? We're going to have to divide it by 4. We're going to get that back again. So we're going to get 0.875 pi again. Let's do that as a decimal now. So as a decimal, that's going to be, let's write here. In fact, let's write here. That's going to be 2.748893.572. And that's going to be meters squared. Yep. Okay. Is that our answer? So obviously, yeah, I can't buy 2.7. I can't buy 0.7 of a tin. So I'm going to need... Oh, sorry, that's not meters squared. That's going to be tins, isn't it? Yeah. So that's going to be how many tins? So I need 3 tins. Yeah, because 2 wouldn't be enough. There's your answer, 3 tins. Yep, that is your final answer. Let's have a look at the next one. Extension question 7. Total surface area of a cube is 150 centimeters squared. Work out the volume. Again, let's work backwards. Let's draw what they're talking about. There's my cube. What's special about a cube? All the faces are the same. All the sides are the same. So I've got 6 faces. Let's work out what one face is. 150 divided by 6. 25. Yep, again, I can see where this is going. Let's call that x. Let's call that x. So x squared is equal to 25. What's x going to be? Square root, which is 5. Okay, so it's going to be volume is going to be 5 times 5 times 5. 125 centimeter cubed. Let's write that there. Dead easy. Extension question 8. Diagram shows water container is 2/3 full with water. The water is going to be used to fill cups. Each cup, I should say, holds. 1 second. Let me change that. That's a typo. Each cup holds 175 milliliters of water. How many cups of water can be completely filled with the water from the container? Okay. Yeah, definitely to do with volume. Let's work out the volume of this. That's going to be 15 times 12 times by 14. Yeah, just multiply all 3 together. Quick way. For a cuboid, it's going to be 2,520 centimeter cubed. So they're saying it's 2/3 full. So what's 2/3 of that? It's 2/3 of that. Let's work out 2/3 of that times by 2/3. 1,680 centimeter cubed. Okay, so that's how much shit is full of water. Right, and then how many of these go into that? Well, that's in milliliters though. So you need to know that 1 centimeter cubed is equal to 1 milliliter. You need to know that. That is a very important measurement, which sometimes they don't even say in the exam, but you need to know that. That's from functional skills. So anything to do with capacity or volume, you need to know that 1 centimeter cubed is equal to 1 milliliter. They might not even tell you in the exam. It's not on the formula sheet or anything. So that's going to be the same amount for milliliters as well. So it's going to be 1,680 milliliters. It's the same. Yeah, for one centimeter cubed is equal to 1 milliliter. It's going to be the same. There's literally no working out for that. And now we can do that divided by 175. How many 175s go into that? 9.6. That's going to be cups. How many cups of water can be completely filled with water? So 9 and a bit. So definitely 9 cups is my final answer, because I can't fill 10 cups. Just be careful. Completely filled has to be. That's the key bit here. Completely filled. I mean, how many can you completely fill with water? And it's only 9. Technically, you got 9 and a bit, so you don't include that bit. So your final answer is 9 in this case. Yeah. Just be careful with that one. Let's move on. Some concrete has volume 3.8 meters cubed. Density of the concrete is 2,400 kilograms per meters cubed. Work out the mass of the concrete. This is to do with mass, density, volume. That is the triangle. Don't have to use a triangle. I do. I think it's pretty cool. Loads of people don't like it. Which order is it in? So don't marry Vera. Or some people said David marries Victoria. That's another way of remembering it from left to right. Which one are we working out the mass? So you cover up the mass. So you're doing density times the volume, which is going to be 2,400 times 3.8 times by 3.8. 9120. Yeah, and that's going to be in kilograms. It's going to be the same. What's happened to this? Yep, that's going to be in kilograms. That's going to be in the same units. Yep. Next one, part B. Well, it's part of the same question. 3.8 meters cubed of concrete is made into the shape of a cylinder. The base has a radius of 0.5 meters. Work out the height of the cylinder. So in fact, it's part of the same question. The only similarity it's got is to do with the concrete. I mean, it's got nothing to do with anything else. 3.8 meter cubed of concrete is made into the shape of a cylinder. The base has a radius of that. Work out the height. So we're told what the volume is. Told the volume is that. Okay. So when you're told the volume in the question, you have to work backwards. And then we can work out the height, which we definitely need. Let's call that H. So what's the formula? Volume is area of the cross-section, which we'll look at in a minute, times the height in this case. Okay. Well, the area of the cross-section is technically that bit there. That's the cross-section. So what's the area of the cross-section going to be? Pi times r squared. Let's work that out. So area is pi r squared. That's going to be pi times 0.5 squared. No 0.25 pi, let's call it. Okay, we're told the volume, 3.8. We know what the area is now. That's 0.25 pi times the height. So the height is going to be 3.8 divided by 0.25 pi. Let's work that out. 3.8 divided by, should get 4.831027. Let's just write that whole thing there. Oops, that's a bit weird. Yep, it didn't say give your answer correct to 1 decimal place, 2 decimal. I'd write the whole thing just to be on the safe side. You know, it's only going to take you less than a few seconds anyway. So, yeah, there's your answer. 2 marks. Let's see. Is this the last one? Yep, last one then. Taken from AQA paper. Ashraf is going to put boxes into a crate. The crate is a cuboid measuring 2.5 meters by 2 meters by 1.2 meters. Each box is a cube of length 50 centimeters. He does these calculations. Volume of the crate 2.5 times 2. Right. Okay. Is that right? 2.5 times 2 times 1.2 gives you 6. Yeah, that bit's right. Okay. Volume of one box. Right. Did that divided by that is 48. This is one of those questions where you've got a small box and you got a bigger box. Does it fit exactly? Let's double check. I don't think it does. So, like I said before, you work out the volume of the small box, work out the volume of the big box, which is what he's done. See how many of the small boxes go into the big box. I wouldn't recommend it. It's not a good idea because in this case, what have you got? 2.5. Let's call that 2.5 meters. Let's call that 2 meters. And let's call that 1.2 meters. That's what they're saying. And this is 50 centimeters. Well, 50 centimeters by 50 centimeters. That's 0.5 by 0.5 meters. 0.5 goes into that. That's fine. If you divide that by 0.5, that's fine. Just go into it exactly. How many 0.5s go into that? 4 times. You can't divide this by 0.5. It doesn't work. You're going to get a decimal. So you're going to get, what that means is it's not going to fit exactly in this box. These little boxes, you're going to have, yeah, you'll fit a few, but then you won't be able to fit some more. So you'll be able to fit 2 of those boxes, but then you'll have a little bit of a gap because obviously how many 0.5s go into 1.2? Well, think of it this way. That's one and a bit meters, isn't it? That's 1 meter and a bit. So you can definitely fit in the 1 meters. You can fit 2 boxes in the 1 meter, but then the 0.2 of a meter, that's like 20 centimeters. You can't fit another box there. So you can have a gap if you can visualize it. You can have a gap there, definitely. So it's not going to fit exactly in this big crate. So his calculations are wrong. You can't work out the volume of the big crate, work out the volume of the box, see how many of those go into that. You can't do it that way. So he's wrong. He thinks he can put 48 boxes in the crate. No, you can't. You can only do, let's work it out. In fact, let's work it out. 2.5 divided by 0.5 is 5. 5 goes into that. So you've got 5 boxes going this way. Yeah. Got 5 going that way. Going this way, it's going to be 2 meters divided by 0.5. So 2 meters divided by 0.5 is equal to 4. So you can have 4 going this way. Yeah. And then for this way, 1.2 divided by 0.5. 1.2 divided by 0.5. You're going to get, let's see, let's work it out. 1.2 divided by 0.5. Obviously, it's decimal. 2.4, it's like I said, which equals 2 and a bit. So you obviously can't have a bit of a box. You're going to have to ignore that bit. So you can only have 2 that way. So you can only fit 2 boxes this way. 5 times 4 times 2. 5 times 4 times 2 gives you, what's that? 20 times 2. That's 40. You can only fit 40 boxes. Oops, that's not how you spell it. 40 boxes can only fit. So he's wrong. Evaluate Ashraf's method and claim. So you have to say that you can't fit 48 boxes in there. So evaluate Ashraf's method and claim. So you have to say he thinks, okay, so he thinks he did it this way. So he did this. So he can't use that though. He can't use 1.2 because you have to say 1.2. You can say 50 centimeters does not fit in 1.2 meters. That's the first thing. Yeah. And the second thing is you have to say that only 40 boxes can fit in the crate. So he's wrong, so it can't be 48. And there's your 2 marks right there. You'll figure it out yourself. So you can't use this method where you do the volume of the big box, work out the volume of the small box, how many of the small ones go into the big one. You're going to have gaps in there. It's not always going to fit exactly in there, as we can see in this example. Okay, that was the last one. I shall see you in the next video.